Hello everyone, welcome to the video lecture series of Engineering Hydrology. In this particular video lecture, we are going to discuss about the types of precipitation. But before knowing about the types of precipitation, we should know about the forms of precipitation. So first of all, what is precipitation actually? What is precipitation? See, in the last class, we have discussed that what is precipitation, right? We know this is the all forms of water that reaches to earth surface. Okay, so this is known as precipitation. Okay, but what are the forms of precipitation? Generally people think that the precipitation is only rain, but that's not correct. Rain is a form of precipitation, but all the droplets that are coming from the sky is not actually precipitation. Okay, so the first form of precipitation is obviously our rain, right? So the forms of precipitation. The forms of precipitation. The first form is rain. Okay. Now, this rain is basically the principal mode of precipitation in India. It is the principal mode of precipitation in India. Okay. Generally, any water droplet whose size is, any water droplet size around 0.5 mm to 6 mm is known as rain. Okay, it is rain. Any size within this 0.5 mm to 0.6 mm is denoted as rain. Okay, it means the minimum size of rainwater droplet is 0.5 mm. Okay, but at the same time, the maximum size of rainwater droplet is 6 mm. Okay, so this is an important point, that the minimum size of rainwater droplet is 0.5 mm and the maximum size of rainwater droplet is 6 mm. Suppose a water droplet is size has lesser than 0.5 mm, then we do not call it as rain. Okay, and in the same way, any water droplet whose size is greater than 6 mm, that is also not considered as rain. Okay, now depending upon the intensity, okay, depending upon the intensity of rainfall, rain has classified into 3 groups, or you can say types. Okay, so depending upon the 3 types, depending upon the intensity, Okay, depending upon the intensity of rainfall, rain has classified into 3 types, okay, or groups. The first one is light rain. Okay, light rain. The second one is moderate rain. Moderate rain. And the third one is heavy rain. Okay, heavy rain. So number 1, 2, and 3. Okay, and as I say, these are classified, in terms of intensity or depending upon the intensity. So the intensity of light rain is 0 to 2.5 mm per hour. Okay, the intensity of moderate rain is 2.5 mm to 7.5 mm per hour. Okay, the heavy rain is any intensity of rain that is greater than 7.5 mm per hour, that is known as heavy rain. Okay, so see, I'm repeating again all these things, that rain is the principal mode of precipitation in India. Okay, the minimum size of rainwater should be, the minimum size of rainwater droplet should be 0.5 mm. Okay, and the maximum size of rainwater droplet is 6 mm. And depending upon the intensity, depending upon the intensity of rainfall, rain has classified into 3 groups, and these are the types. Let me write here, these are the types. Okay, these are the types, and these are the intensity of those particular types. Okay, this is intensity, right? Now the second form of precipitation. Okay, from this data, you may understand or you may observe that the rain is generally measured in terms of depth, because you can see here the unit of the rain is mm. It means that generally what happened in India or in the most of the countries, the rain is measured in terms of depth. Okay, so I write here a note point. Note that rain is measured in terms of depth. Okay, and if you want to calculate the volume of the rain, then just just multiply that depth with the area. Okay, and you will get the volume, right? We know that area into depth is what? Is volume. So if you want to calculate the volume of rain, then we just need to multiply that measured depth of rain with the area. Okay, now the second form of precipitation, the first one was rain, and so the second one is drizzle. Okay, the second one is drizzle, right? So what is drizzle? See, any water droplet whose size is 0.5 to 6 mm is rain, but a water droplet whose size is lesser than 0.5 mm, that is known as drizzle. Okay, so any water droplet whose size is less than 0.5 mm. Okay, this is known as our drizzle. Okay, now the third form of precipitation. The third form of precipitation is snow. We all know what is snow basically. The snow consists of the ice crystal. Okay, it consists of, let me write it with another color. It consists of ice crystal. Okay, and it's the density of this ice crystal, are generally 0.6 gram per meter cube to 1.5 gram per meter cube. Okay, this is the density of those ice crystal. Okay, so snow is a form of precipitation which consists of the ice crystal. Okay, and its density is 0.6 gram to 1.5 gram per meter cube. You can take it on an average. The average density is 1 gram per meter cube, you can assume. Okay, so this is our snow. So next form of precipitation is sleet. Okay, the next form is sleet. So what are these sleets? These are basically the frozen raindrops. Okay, these are the frozen raindrops. The frozen raindrop having transparent grains. These are frozen raindrops having transparent grains. Okay, generally the sleet forms, these are sleet forms at sub-freezing temperature. Okay, sleet forms at sub-freezing temperature. Okay, now the next form of precipitation is hail. Okay, the next form of precipitation is hail. What are the hails? These are lumps of ice that comes from the sky, having size greater than 8 mm. Okay, so these are lumps of ice that is coming from the sky. Okay, and its size is greater than 8 mm. This is important. Its size is greater than 8 mm. Okay, now the last one of the form of precipitation is glaze. Okay, glaze. So what is glaze? Basically these are maybe raindrops or maybe drizzle. Okay, these are raindrops or drizzle, but when they comes to the ground surface, they becomes ice. Okay, why they become ice? Because due to very low temperature of ground surface. Okay, and suppose this is ground surface. Okay, this is ground surface and raindrops is coming from the sky. Okay, and the temperature the temperature of this ground surface, this is our ground surface, the temperature of the ground surface is 0 degree centigrade, suppose. So what will happen? When this raindrops will reach the ground surface, it will becomes, ice, because at the temperature of 0 degree centigrade it will become ice. Okay, so these are the forms of precipitation. Okay, now we are going to discuss about the types of precipitation. Okay, the types of precipitation. Types of precipitation. So the first type of precipitation is frontal precipitation. Okay, frontal precipitation. Okay, so what is this frontal precipitation? Let's discuss. Suppose this is our ground level. Okay, this is our ground level. Now when a warm air mass, this is the air mass, and a cold air mass, suppose this is cold air mass. Okay, this is cold air mass. When a hot air mass, this is our hot air mass, and this is our cold air mass. When this hot air mass and this cold air mass meets together in a favorable condition, what will happen? This warmer air mass, this hot air mass will lift upward. Okay, this warmer air mass or hot air mass will lifts upward, and this cold air mass will settle down. This cold air mass will settle down. Okay, and this hot air mass or this warmer air mass, when it lift up at the high altitude, it cool down adiabatically and it forms cloud. Okay, after cooling down adiabatically, it forms cloud, and for obvious from that this clouds precipitation occurs. Okay, so this is known as frontal precipitation. Okay, I'm repeating again. When a warmer air mass and a cold air mass meet together at a favorable condition, the warmer air mass lift up to a higher altitude and the cold air mass settle down. Okay, this cold air mass settle down. Okay, and the warmer air mass at the higher altitude cools down adiabatically and forms the clouds. This is clouds. Okay, this is cloud. It's cloud, and for obvious from that cloud the precipitation occurs. This is precipitation. So this is known as frontal precipitation. Okay, now the second one is our convective precipitation. Okay, the second one is convective precipitation. Okay, what is this convective precipitation? Suppose this is our earth's surface or ground level. Okay, now suppose due to localized heating, if the warmer mass or warmer air rise upward. Okay, due to what? Due to the localized heating, the warmer mass rise upward due to its less density, right? The warmer mass has lesser density than the cold mass, so that's why it is lifting himself upward. Okay, and the cold mass from surrounding area, suppose these are the cold air mass from surrounding area, they takes this void space. Okay, they takes this void space of this this warmer mass, because this is the space previously it was occupied by this hot air mass, but since due to its less density it's lift upward. Now the cold air mass from surrounding takes this void space of this warmer mass. Okay, now what will happen? as we see in frontal precipitation, this hot air mass will rise upward and at higher altitude it cools down adiabatically and forms cloud. Same as our frontal precipitation, it forms clouds. Okay, and from that clouds, what will happen? The precipitation will occur. This is cloud. So this is all about the convective precipitation. I am repeating again, due to the localized heating, the warm air, what will happen? The warm air rises because of its lesser density. Okay, and the cool air from surrounding takes up that void place. Okay, this cool airs takes up the void space. Okay, and thus it setting up a convective cell. Okay, that is setting up a convective cell. Okay, and this warmer mass which lift upward itself, it will cools down adiabatically and it will form a cloud. Okay, and after forming cloud, from the cloud precipitation will occur. So this is known as convective precipitation. Okay, now the third one is our orographic precipitation. Okay, our orographic precipitation. Suppose air is moving from this direction to this direction. Okay, it is moving or flowing horizontally from left to right. Now suddenly it get a barrier. Okay, it get a barrier such as mountain. Suppose this is a mountain, and due to this mountain barrier, what will happen? This air mass will not able to move horizontally anymore, so it will rise in this way. It will rise or it will move up vertically in the higher altitude. And in the same way as frontal precipitation and the convective precipitation, after going upward, it will cools down adiabatically and forms clouds. Okay, and after forming clouds, from that cloud precipitation will occur. So this is known as orographic precipitation. Okay, I'm repeating again, due to the presence of any kind of barrier such as mountain, the moist air may get lifted to a higher altitude instead of moving forward. This moisture which lifted up at the higher altitude, it will what will happen? It will it cools down adiabatically and forms cloud, and from that cloud precipitation will occur. Okay, now from which side the air was flowing, this particular side is known as windward direction. Windward direction. Okay, and this particular side is known as leeward direction, or not direction actually, this is side. This is not direction, it is better to say it as side, and this is also side. This is side. Generally in windward side, the volume of precipitation or the magnitude of precipitation is higher than leeward side. Okay, so here the magnitude of rainfall is higher. Here the magnitude of rainfall or precipitation, you can say, is greater in windward side, and this leeward side precipitation is less. Okay, so this is our orographic precipitation. Now the fourth one is cyclonic precipitation. Okay, this is cyclonic precipitation. The fourth one is cyclonic precipitation. Okay. So before knowing about cyclonic precipitation, we should know what is cyclone basically. What is cyclone? Basically, cyclone is a low pressure area with circular wind motion. Okay. Now, this cyclonic precipitation are of two types. One is tropical, and another is or tropical cyclone, you can say, and one is extratropical. Extratropical cyclone. Okay. So first, let's discuss about the tropical cyclone. What is this tropical cyclone? Tropical cyclone. Okay. Now, this tropical cyclone is also known as just cyclone in India. Okay, in India, this tropical cyclone is only known as cyclone. Now, this this tropical cyclone is also known as hurricane in USA. Okay, and this tropical cyclone is also known as typhoon in Southeast Asia. In Southeast Asia. So actually, what happens in this tropical cyclone? Let's see. The air from the surrounding, suppose this is a low air mass region. Not low air mass region, this is a low pressure region. This is a low pressure region. Okay, this is a low pressure region or area maybe. So in this low pressure area, from surrounding, air will come here. Okay, I am showing you a plan view. Okay, this is a top view. So in this area, in this low pressure area, air will come or wind will come, and then it will flow in a circular motion. Okay, it will flow in this way in a circular motion. Okay, and due to this circular motion, what will happen? Due to this circular motion, the density of air will decrease. Means due to this circular motion, the wind becomes warmer. Okay, and due to that, it will lose its density and it will move upward. And after moving upward, what will happen? In the same way of frontal precipitation and that convective precipitation, after moving it upward, it will cools down adiabatically and condensed and form cloud, and for obvious it will precipitate from that cloud. Okay, so this is known as cyclonic precipitation or simply the tropical cyclone. Okay, now generally the areal extent of tropical cyclone or simply cyclone is 100 to 200 kilometers. Okay, this is an important point. The areal extent of a tropical cyclone or cyclone is 100 to 200 kilometers. Okay, generally the center of this cyclone, suppose this is the center, this is the center of the cyclone. This center of cyclone is known as the eye of cyclone. Okay, this eye of cyclone, this is known as the eye of cyclone. Okay, the velocity of the wind, outside the eye is very high. Okay, the velocity of wind, suppose this is I. let me draw here. Suppose this is eye of the wind. Okay, if this is the eye of the wind, the velocity of wind is as much as higher of 200 kilometer per hour. Just this outside of this eye. This is outside of the eye, and this outside of the eye, the velocity of the wind is almost 200 kilometer per hour. Okay. Now during the summer, what will happen? This tropical cyclone originate in the open ocean, and when they reaches to the land, their intensity decreases rapidly, but still it causes heavy damage. This is causes heavy damage. It causes heavy damage. Okay, of life and the property on their path. Okay, generally the tropical rainfall gives the moderate to excessive rainfall. Okay, it gives the tropical rainfall. The tropical rainfall gives moderate to heavy rainfall. To heavy rainfall. Okay, this is another important point. Okay, and generally the precipitation occurs over a large area. Okay, of order of 10 into 10 to the power 3 kilometer for several days. Okay, so the precipitation occurs over a large area of a order of 10 to the power 3 kilometer for several days. Okay, so this is all about the tropical cyclone. Now we'll discuss about the extratropical cyclone. Extratropical cyclone. Okay, so this type of cyclone form outside the tropical zone. Okay, this cyclone poses a strong anti-clockwise wind circulation in north hemisphere. Okay, it means suppose this is our this is north hemisphere and this is south hemisphere. Now in north hemisphere, this cyclone possesses strong anti-clockwise wind. Okay, anti-clockwise wind in this way. So the motion of this extratropical cyclone is anti-clockwise in northern hemisphere, and in southern hemisphere its motion is clockwise. So this is known as extratropical cyclone. Okay, and in this extratropical cyclone, the magnitude of precipitation and the wind velocity is relatively lower than tropical cyclone. Okay, the magnitude of precipitation and the wind velocity is lesser than tropical cyclone. Okay, and tropical cyclone. This is an important point. Okay, now this is all about the cyclonic precipitation. Okay, now we are going to discuss about the last type of precipitation. Okay, that is anticyclonic precipitation. Okay, this is anticyclonic precipitation. This is number 5. This is anticyclonic precipitation. So basically anticyclonic precipitation is just opposite to cyclone. Okay, let's see here. In cyclone, what happens? This is a low pressure area. This was a low pressure area, and from this, and in this low pressure area, from surrounding the air, the surrounding air comes in this low pressure area and forms cyclone. But in this anticyclone, what happened? There is an area which have a high pressure. Suppose this area is a high pressure area. Okay, this pressure is a high pressure area. Okay, and in this high pressure area, from surrounding, the air comes here. Okay, in this high pressure area and forms anticyclone. Okay, unlike the cyclone, the magnitude or the velocity of wind is less in this central area, and the magnitude or the velocity of wind is much higher in the outer side. Okay, suppose this is the outer side, and this outer side, the magnitude of the velocity of the wind is much higher. Okay, generally the anticyclone has a strong clockwise wind circulation at the northern hemisphere, just opposite to this extratropical cyclone. Okay, what I'm saying, if this is northern hemisphere and this is southern hemisphere, then what will happen? This anticyclone has a strong clockwise wind circulation in northern hemisphere. So this is a clockwise wind circulation in anticyclone precipitation in northern hemisphere, and in southern hemisphere it has, it will be like this. It will be anti-clockwise. Okay, in the southern hemisphere, in this way. Okay, it is just just opposite to this extratropical cyclone. Okay, now this is all about the forms of precipitation and the types of precipitation. This is it for today. We'll meet again in the next class. Thank you.